Okay, welcome back. So we've been talking about acids and bases, and the last thing we had just done was learn about Kw. Remember Kw? It's all based on this equilibrium. That water reacts with itself in equilibrium with the hydronium ion H3O plus and the hydroxide ion OH minus. That led to our equilibrium constant, Kw, which is the concentration of H3O plus multiplied by the concentration of OH minus. And remember, we actually knew the numerical value of Kw was 1.0 times 10 to the minus 14. All right. But if you've done any of the practice questions surrounding Kw and using Kw, you've probably found that you're always dealing with tiny little concentrations. Things are like to the minus 13 or the minus 12, even the minus 6, minus 7. What we're going to talk about today is a system and a scale that was developed that changes all of these really tiny numbers into an easier to understand system. And that is what is called the pH. Now, you probably have heard of pH. If you have a hot tub or a swimming pool at your house, I don't know who has a swimming pool at their house, but let's just pretend you do, then you probably know about pH. You probably just know it in general from like life and understanding, pH is a thing. But here's what pH actually is. In chemistry, a lowercase p stands for the negative logarithm. Now, if you haven't taken logarithms in math, don't panic. All you need to really know how to do is to use the logarithm function in your calculator. That's what you need right now. But if you don't know what a logarithm is, basically a logarithm is going to take really, really big or really, really small numbers, make them a little bit easier for us to understand. Okay? So when we say pH, remember p is the negative log. H actually represents H plus. Remember, another way of saying H3O plus is to say H plus. Remember, H3O plus is the same as H plus. It's just we've taken the water out. We've taken the H2O out. And we get this. So the concentration of H plus taken to the negative logarithm is the pH. Okay, if you have a calculator, here's what I want you to do. I want you to actually just punch in the negative logarithm of 1.0 times 10 to the minus 1. What you're going to find out is it comes out to be 1. Negative logarithm of 1.0 times 10 to the minus 2. You're going to find out it becomes positive 2. If you were not to put the negative in, basically what happens is it takes 1 times 10 and then whatever the exponent is, turns it into a whole number. Right? Same thing here. It would have made it negative 2. But because we add the negative in front, it removes that negative sign for us from the exponent. And so we deal with a positive scale when we deal with the pH. Here's the last one I want you to punch in. The negative logarithm of 1.0 times 10 to the minus 7. You're going to find that 7. Okay, do you remember when I said pure water has this as its Kw, but remember that came from knowing the concentration of H3O plus and the concentration of OH minus. They were the same in that solution, and they were 1.0 times 10 to the minus 7 molarity. So in pure water, because that's the concentration of H3O plus, you get a pH of 7. That's why 7 represents like pure water, or what we would consider to be neutral. 7 is when you have equal amounts of H3O plus and OH minus. It's not acidic, it's not basic, because you have the same amount of each one. So maybe we should actually now think about what this actually means. If you have a much higher concentration, you're going to get a lower number. And so what that means is the pH, if it is less than 7, it actually meant that you have a high amount of H3O+. So that tells us that you have an acidic solution, more H3O+ than OH-. Let's say you had a pH that was greater than 7. Well, what that actually meant is you had a really small exponent, a low amount of H3O+, less H3O+ than OH-, because remember, those two are working in tandem. That's basic. The concentration, or the pH, when we have a concentration of 1.0 times 10 to the minus 7, means that we have the same amount of those two. That means it's neutral. Probably spelled that wrong, didn't I? You know what I meant to spell. I don't know. I can't spell. Just a science teacher, not an English teacher. So that's what we really use this for, because if you use the pH, you can actually look at this and be like, okay, acidic, basic, easy to figure out. But when you're looking at all these concentrations, it's a little bit harder, especially for people who may not be like super into chemistry and not actually chemists. You know, somebody who's testing the swimming pool, somebody who's like, you know, just doing their job that doesn't really require them to know a ton of chemistry. They don't really need to know the concentrations, but the pH they can understand and work with. Here's what we're going to do. We're going to do an example. We're going to have a solution. A solution of HCl, or hydrochloric acid, has a concentration of HCl that is equal to 0.50 molarity. What is the pH? The pH. All right, remember last example I did with you? The first thing I said you need to do is look at the substance you have. Ask yourself two questions. Is it an acid? Is it a base? Well, HCl, hydrochloric acid, is an acid. Second question, is it strong or is it weak? Well, take a look at your strong acids. You will find that HCl is on there. This is a strong acid. Figure out what this means. Strong, use stoic. So what that means for us is we're going to use a balanced equation of HCl reacting with water, strong acid, so one-way arrow, producing H3O+, and our conjugate base Cl-. We know that the concentration of HCl is 0.50 molarity. So what's the concentration of H3O+? Well, we need to use a little bit of stoichiometry. And again, I'm going to write it out. Hopefully you've already figured this out and don't need me to write this out. But we're going to set up our molar ratio. There is 1 mole of H3O+ for every 1 mole of HCl. HCl cancels, and you're left with 0.50 molarity is our concentration for H3O+. So now that we know that, we know our concentration of H3O+, well, let's figure out the pH. The pH is the negative log of the concentration of H3O+. So the pH is the negative log of 0.50 molarity. Punch that into your calculator, because who can do logs in their head? You're going to come out with an answer of 0.30. Now, pH has no units, so you just got to write that number out. 0.30 molarity. Or so, not even molarity. Oh, what am I talking about? It's just pH. pH is 0.30. Okay, so there. That's what we need to know. We need to know that to calculate the pH of a solution, we use that formula. But what if I know the pH? And let's say I wanted to know the concentration of H3O+. Well, if you are a math whiz, you probably already know this. But for the rest of us, let's say you wanted to find the concentration of H3O+. There is a function that's called the anti-log, basically like the reverse of a log, to get rid of it. So if you're like I said, if you're a math whiz, you can probably derive this equation and figure it out, but for the rest of us, this is all you need to know. The concentration of H3O+ is 10 raised to the exponent of the negative pH. You put that in, that'll solve what concentration of H3O+ you're dealing with. Okay? So let's do it. Let's do an example. Let's say a solution has a pH of, let's say, 8.3. Remember, no units. What is the concentration of H3O+? Well, all we need to do is plug that into our formula. So 10 raised to the power of negative 8.3 is going to give me my H3O+ concentration. And that is 5.01 times 10 to the minus 9 molarity. And there it is. Okay, so the pH isn't really that hard to work with, and actually it's kind of helpful and useful, but you do have a couple of formulas that you need to be able to work with. You need to be able to calculate pH, and so to calculate pH, remember it's the negative log of the concentration of H+. Remember, little p, negative log. You also need to be able to find the concentration of H3O+ given the pH. Remember, 10 raised to the power of negative pH. That's what we're learning about here, is using the pH. Next up, I'm hoping to put together a little short video, because it's not just the pH. There's also something called the pOH, and that's coming up in the next video. Okay, thanks. See ya.